And my topic is cooperative properties of enzymes. The steady state kinetics of the enzymatic reaction often differs from the mechanism kinetics in the curve showing the dependence of the reaction velocity v on substrate concentration s and r modifier concentration display inflections maxima and plateaus. An example is given below which present the curve of v versus s. The curve of v versus s as aspartate transcarbamylase, the EPSICA shows the concentration of aspartate into the 10 power 3 mole per liter. Symmetric representation of the reaction with the enzymatic consisting of the two subunits. For aspartate transcarbamylase, S is aspartate in the absence and presence of a modifying reagent citidine and a triphosphate. Next. In the first case, the curve is sigmoid rather than the hyperphilic in the shape. As a rule, these features are accounted for by presence of a quaternary structure in the enzyme and by the interaction of the subunits. The behavior of the enzyme is cooperative and affinity for the substrate and the catalytics of a particular subunits. Promoter depend on the states and other subunits are in the whether they have bound the substrate or not. Let us consider a simply model of the enzymes. Molecules composed of two interacting identical subunits. Each of the subunits has an active site. The scheme of the steady state process is the depicted in the figure is given below. The scheme of the steady state process is depicted in the figure 6.17. The enzyme molecules can exist in the three states. The fact that the V and SY curves show some singularities under the steady state accordingly equilibrium conditions is the indication of the cooperative. The absence of the such singularities does not necessarily mean that no cooperative model has been processed by the changes. The model by the oligomers consisting of the two or more identical subunits. The some symmetry it may build up of the isologous or heterologous manner. In the later case, the oligomers may be long in the length. Each subunit contains the binding site for each ligands, substrates, and modifier. It is presumed that the oligomers as a whole can exist in two or more conformational states. The affinity for the ligands varies with a change in the state of the oligomers, such as the system is cooperative without loss of the generality. Let us consider a diameter which can exist in the two states designated R and T. In either of these states, the dimer is capable of the addition of 0 or 1 or 2. We can see here in this figure the possible structure of the isologous and heterologous diameters and of a heterologous polymers. The cooperative phenomenon in which the affinity towards the corresponding ligands is reduced as the active site are saturated more and more. Detected in the 1956 the existence of the sequential enzymatic reaction in which the end metabolism affect the activity of the enzyme and catalyze the first reaction in the sequence. We know at present many such systems called allosteric system. In particularly case of the inhibition have been established whose kinetics is isomers to the kinetics of the competitive inhibitors through the structure of an allosteric inhibitor is different from that of the substrate. For instance, as per the this end product of the chain of the reaction inhibits aspartate transcarbamylase. Allosterism is an important phenomenon that provides for the regulation of the enzymatic action at the molecular levels. The presence of regulation of the biochemical process means the existence of the direct and feedback channels through which appropriate information is transmitted. The transmission of the information in the cell is the transmission of the chemical signals, example molecules and ions. The cell contains substance whose reactivity is determined by the action of the molecular signals on them. Since such signals come from the enzymes, it is the enzymes that are the subunits to the effect of the chemical feedback. One may come to the logical conclusion of the existence of the regulatory enzymatic system. We have already said that an enzyme may be regarded as a signal transmitters the input signals. The substrate is transformed to the output signals like the products. If the about signals, output signals affect the operation of the transformation. A feedback is realized positive or negative depending on the whether and the other products activates or the inhibits the function of the enzymes. An investigation of the allosteric enzymes has shown that they obsess of the quaternary structure and the cooperativity. And log v upon v max and n log s and log k. And the kinetics of the allosteric is depicted as follows: log v upon v0 minus v is equal to log k and n log I. Here v is the steady state velocity, v max is the maximum velocity, and v0 is the velocity at I is equal to 0, k and k are constant. Properties of the enzyme. Let us assume that the enzyme molecules that has converted the substrate into the product emerges from the reaction is an active conformational state. If the relaxation time, the time of the rectum of the original and standing state is longer than the time between the encounter of the enzymes with the substrate are of the some order, then the kinetics may stimulate cooperative kinetics. Solving the appropriate equation of steady state kinetics, we obtain the reaction velocity v is equal to as square plus bs upon cs square plus ds plus k, where a b c d k are combination of the kinetic constant. We have dealt about with only relatively simply enzymatic process. In more complicated cases, calculation even under steady state condition become unusually. Thank you, ma'am.